In 2022, more than 37 billion tons of CO2 were added in the air. With emissions continuing to rise, capturing carbon and putting it back in the earth is vital. But the current carbon capture technologies are very energy intensive. Removing one-fifth of the United States' annual emissions would bring the entire electricity output of the country. To bring our world to net zero, we have to think of creative ways to not only reduce emissions, but also remove them from the air. At Respira, we envision a world where we use the power of nature to work towards a net zero carbon world. We aim to do this by printing existing fabrics with algae, which can capture carbon dioxide from the air and emit oxygen with no energy input while in use. We have created a bioink made from the algae called sea rain hati, which can be printed on fabrics containing cellulose, like cotton and linen. Algae has an ability to capture and reuse up to 1.8 kilograms of CO2 per 1 kilogram of algal biomass, which is almost twice its own weight. But you would think, why use textiles to capture carbon? We chose textiles because of their huge production. 27 million tons of cotton are produced in 1 year, and bioink can be applied on cotton. Our solution has the bioink containing algae and other additives. This is about a centimeter thick layer which sequesters CO2. Between the fabric and the ink, we lay carbon nanotubes, which helps to transport nutrients and water, like the veins in a leaf. They transport from a waterproof pocket at the top of the textile so we can use gravity. To make sure the nanotubes stay in place, we add gelatin to the ink, which increases its adhesive properties. The users will only need to add the nutrient mixture once in an attached container, and the sack will be filled at regular intervals. This has sensors to measure the changes in the environment and reduce the supply of nutrients when conditions promote excessive growth of algae, so we can also control biomass production through this. Our bioink consists of additives such as metal organic frameworks, aminosilica adsorbents, and zeolites, which absorb CO2 into the matrix, increasing the contact with algae and improving the efficiency of photosynthesis by 100-fold. All of these are embedded in a matrix made from sodium alginate, which helps in retention of water and transfer of nutrients to algae. Now let's dive deeper into the process. This is very interesting. So first, we grow the algae in carbon-supplemented agar for 4 weeks in photomixotrophic conditions. Then we take the viable cells to add into the bioink with other additives. This creates a composite material that can capture CO2 from the surrounding environment. Then we layer the nanotubes at regular distances of the fabric before bioprinting the bioink on it. An extrusion-based bioprinter is used for patterning microalgae on top of the fabric. This fabric is also lined with calcium chloride, which reacts with sodium alginate, forming alginate hydrogel, in which microalgal cells are immobilized. The technology gives us an ability to bioprint microalgae as mono or multi-layered constructs into various geometries and sizes. Some of the products we can use this in are curtains. There are billions of square meters of textiles like curtains that receive sunlight every day, but they aren't using that energy at all. If 1/10 of the buildings had our curtains, they would absorb 2 billion tons of CO2 per year, which is 5% of the annual emissions. Our technology allows manufacturers to build carbon neutral products without changing their entire manufacturing process. We will be the first ones to commercialize bioink for garments. Our target companies include Decor from India, which is the largest curtain producer in the world. Companies like them could help their native countries reach their urgent climate goals. For example, India's pledge to reach net zero emissions by 2070 was one of the most important announcements at COP26. Curtains is just one product among others like stadium covers. We can also use this fabric in outdoor parasols and gazebos. In the future, we also aim to make this into clothes when our technology can sustain without long exposures to sunlight. Some of the things we aim to tackle with more research are lengthening the life of algae. Currently, the data shows that it can survive for more than 4 weeks, but we will work to prolong its life to 6 months to make it a convenient product for the consumer. The high cost of carbon nanotubes may be a barrier, and the toxicity related to its long exposure still need to be measured. At Respira, we aim to give people the power to fight against climate change through making sustainable choices. Come join us at Respira to help us build a carbon neutral world for generations to come. Thank you.
Okay, thank you, Ada, for that pitch. Please keep your slides up in case the judges want to refer to any specific slides or diagrams that you've shared. But we're just going to open it up. Any questions for Ada in the group? And obviously, Ada, like if your group is here, you can also hand questions over to the folks that worked on those specific parts. But yeah, go for it. We have plenty of time, so we should be able to hear from everyone.
Sure, I'll kick it off. You mentioned at the end of your presentation that the high cost might be a barrier. Do you have a sense of how much more costly this fabric would be compared to competitor fabrics?
Yes, so that depends on how we're sourcing algae. But right now, we don't have a definite cost structure because there are many additives that need to be measured, but we do have a clear understanding of what kind of impact this would have.
Great, thank you.
I just want to make sure that I'm understanding correctly. So the BioInk is a fabric, is it textile that you want to deploy in places that have sunlight, like curtains or outdoor umbrellas or awnings. And then you're hoping it will last a season, basically like 6 months. Did I get that part right?
Yeah, so it's a bio ink. So what we're doing is we're printing existing fabrics with our bio ink. So we're not manufacturing new textiles. We're using existing ones and making them carbon neutral.
I see. And so that 3-layer structure with the cellulose and the carbon nanotube and the algae on the substrate, that together is an ink that you like raster it over an existing textile.
Yes.
And then would you have to recoat it every year?
Yes. So it would, according to our calculations, it would survive for 6 months, and then after 6 months, you'll have to recoat it.
And just one more question: how does that change the properties of the textile? Does it make it stiffer or less robust to weather, or how does it change it?
Yeah. So if I show you the composition of our bioink, so our bioink contains like an alginate matrix, which is very flexible. So we've made sure that the fabric remains flexible. The layer is just 1 centimeter thicker. So that's the type, that's how much algae we're putting on top of it. So, and it is also breathable because it's a hydrogel matrix. So because we need to make sure that the nutrients are being transferred, that's why, so the flexibility and durability part is still taken care of. Thank you so much. Yeah.
Thank you.
And can you talk a little bit, if you have thought about the model of sales, if there's something, if it runs out of its value properties in about 6 months and needs to be recoded, would you consider a subscription model where you're providing post-sale services for this for a certain amount of time? Is it a one-off and then they have to re-up their contract with you? For example, if they're a hotel with a lot of curtains or something like that. Talk a little bit to me about how you imagine staying in touch with your consumers or your clients after that initial 6 months.
Okay. So as you know, our fabric is a living fabric. So we are imagining this to be a subscription-based model. So for large organizations, we can keep in touch with them and like even offer special offers to people who are our long-term customers or our big enterprises, because this needs to be maintained. And also for like, it's just like any other, it's like a very dynamic piece of fabric. So we're not talking about static things, and we also have this nutrient delivery system. So to check that, so yes, definitely a subscription model would work the best for our organization.
Great, thank you.
And could you just explain this a bit more about how you, like, do you know the impact of the sun on these fabrics after 6 months? Like, will it change the color? Will it impact the quality of the look and feel of the texture? Will it impact the quality of the look and feel of the texture?
Mm-hmm. So if algae are very resistant, so algae are known for growing in like harsh conditions, so it wouldn't change the feel of the fabric because we have this hydrogel matrix on top, so it doesn't spoil the fabric. So we're not worried about the sunlight causing a problem.
Okay. I'm just curious, how did you come up with the name of the company?
Respira in Italian means to breathe, right? So we're allowing people to breathe cleaner air because it also emits oxygen. But it's the main thing that we wanted to really focus on was carbon capture because of the huge emissions we're emitting every year.
And if you're talking about kind of a curtain length piece of fabric, do you have an estimate on the amount of time that it takes to coat that and the expertise needed to coat it? If someone has the training, do they need to be highly trained in order to coat the fabric? Can anyone do it? What's the needed human and time cost on this?
Yes. So the process would be similar to any sort of bioprint, like 3D printing. So we use a software called Colido. So Colido is a 3D printing software, and it can be used for other types of material scientific things. So anyone who is familiar with the bioprint, like 3D printing process, can bioprint this. And did you have any other question? Did I miss something?
How long does it take?
Like how like it wouldn't take that long. You know, like it's going to be a pretty fast process. Like imagine like it's just like 3D printing. So we're not rethinking the printing process. We rethought the application of that printing process. So if any company wants to input the time and the cost that it takes to train people to use 3D printing, they can use our technology as well.
Great, thank you.
Lars, do you have something to add?
Yeah, so I did some research. I'm in Adas Group. I did some research on this to begin with, and the process used in the paper where this process was explained, it was quite slow. But the good thing is that the 3D printer they were using was very it was homemade, so it's very, very open to improvement and being able, like the bioprinter is very open to being improved. And it's cheap and it can be upscaled a lot, but the process was quite slow. But some ideas could be like using multiple extrusion heads at the same time to coat it quicker, those kind of things. But yeah, it was quite slow, so it would probably take maybe even up to a day for a whole piece of curtain with the current technology. But it was DIY. They made it in the lab without large manufacturing machines, so it's very open to improvement.
Could you tell me a little bit more about how this would work with fashion and clothing? Because when I think about clothing, obviously people want it to last longer than just 6 months. So what's the process with clothing specifically?
Yes.
Would you encourage like a recyclable program alongside it? And again, it's a subscription-based model again, like would you provide the same garments to those individuals that bought the previous garments?
Yes. So the main challenge that came with fashion, and that was our target market initially, but we shifted from that and shifted to outdoor textiles or textiles that have access to sunlight. Because if you imagine, like most of the times, people keep their clothes in the wardrobe, right? So we would have to envision some sort of grow LED light system for that. And at this point, that is also energy intensive. So in 5 to 10 years, when that grow LED process is less energy intensive and people keep their clothes in their wardrobes and they still have the nutrients and the sunlight, the right conditions they need, if we are able to achieve that through less energy input, then that is a future application. So right now we're not going into fashion.
I just had a question, and I'm sorry if you shared this number and I just missed it. Just going back to the original strategy for focusing on textiles that are inherently made to be outdoors or absorbing sunlight. Do you have an estimate of the CO2 emissions and CO2 that you would avoid, or the reduction in CO2 emissions that you would affect with
Yes.
this?
Sure. So if we take the example of curtains, but like just because they're curtains, like we've calculated this per square meter, right? So if we have like even if 1/10 of the buildings in the world had our curtains, they would still sequester 2 billion tons of CO2 per year. And that is 5% of global emissions. But for more detail on how much per square meter we sequester CO2, I think I can shift the mic to Lars, who did the calculations in much depth.
Yeah, so it is quite a lot actually, because the nanotechnology we're using is very promising. And so the numbers featured in the survey would allow us to generate over 1 kilogram per square meter per day. And that sounds like a lot, but that's what the studies indicate, right? But so any kind of fabric per square meter, it's over 1 kilogram of CO2 absorbed per day.
Okay. Excellent. So I think with that, we'll move on. Thank you so much to Ada and the team for putting this pitch together for us. Let's keep moving. So